the fall, how it ends. It's the fall, how it ends. Or it's the fall.
Greetings of the day. Welcome to the another session of the PhysioTV. This is Dr. Venu Mohan, HOD Electrotherapy Department, Sancheti College of Physiotherapy. Today, I have come up with a new topic for the first year BPTH students, that is the production principles of interferential therapy. In today's lecture, I'm going to discuss about the definition, the common terminology used in interferential therapy, principle of production of IFT, and I'm going to discuss about the block diagram of interferential therapy. And then we are going to discuss advantages of medium frequency over the low frequency current. We are going to talk about the skin impedance and all the parameters used in interferential therapy. So let us first start with the basic layout of the IFT machine. So basically, it contains the following units. On the left-hand side, we have basically the timer. Okay. Then after timer, we have a knob to select the 2000 Hertz and 4000 Hertz. It may or may not be present in all the machines. In most of the machines, they have 4000 mode default. That means 4000 frequency is fixed, whereas 2000 may or may not be present. Then we have different waveforms. And then on the lower inferior or the bottom side, we have the base button. You can see the base button, the sweep. Then we have the modes, different modes, that is 2-pole, 4-pole, and 4-pole vector. And then we have a balance knob to balance between the right and left channel. And then we have the intensity knob. And there are two display units. The display unit for the channel 1 and display unit for the channel 2. And then we have the sockets for the connecting the 4 electrodes, the 2 for the red channel, 2 for the black channel. So first, let us try to understand how is low frequency and medium frequency differing when it comes to the skin resistance. Okay, so we see that from this diagram, we can see that the electrode, and then we have the gel, sweat, skins, basically epidermis, dermis, and the subcutaneous layers. So what happens is they form the resistance in series, and of course there are some capacitance also based on the layers of the skin and the tissue. So basically, this is the combination of the resistance and series. So what is happening is, in low frequency current, the skin offers greater resistance than in the medium frequency current. When you are using the medium frequency current, the skin resistance is low. And if you are using very high frequency, even then the skin resistance will be low. So this issue with application of low frequency and the skin resistance, the solution was found by Dr. Hans Nemec in 1950s. He is one of the famous person from Austria who first explained this phenomena of interferential therapy. So this was described as transcutaneous application of alternating medium frequency current, and which is amplitude modulated at low frequency for the therapeutic purpose. That means basically what we are trying to tell you is, we are using medium frequency current, the two medium frequency current, and we are superimposing them, and finally the output is of low frequency, that of TENS and other machines. Now, whenever it comes to the interferential therapy, there are several terminology which come across: interference, alternating current, electrical current, low frequency effect, medium frequency current, transcutaneous, sinusoidal waveform, frequency modulation, amplitude modulation. So we have a lot of things which come across. So today's lecture, we'll try to solve all this terminology and understand them. So first, basically, let us try to understand what is alternating sinusoidal waves. Sinusoidal and alternating sinusoidal waves is the waveform in which the waves are evenly alternating. That means the crests and troughs in this waveform are same. The current is increasing gradually and decreasing gradually. That is evenly alternating. Then when it comes to the medium frequency current, the range of the medium frequency current starts from 1 kilohertz to 100 kilohertz. Now, how does this affect? I'll tell you. So what does this mean? This means that in low frequency current, in a given time, if there are only two waves that are completing, in medium frequency current, there are several waves which complete in the same given time. Whereas in high frequency, at least 100 times more than what we are seeing in the medium frequency current. So basically, in a given time, if there are, based on that, how many waves are formed, that based on that, they are either classified into low, medium, and high frequency. If their frequency is, if their number of waves in a given time is around 1000, that is 1 kilohertz to 100 kilohertz, we call them medium frequency current. And when it comes to the commercial IFT and the therapeutic application of the IFT, we use the two commonly used frequencies are 2 kilohertz and 4 kilohertz. Now, let us go to the actual principle of production. So here the idea of producing interferential therapy and thereby producing the low frequency effect is this. So there are two medium frequency currents taken into account, which are slightly different frequency, which have slight difference in their frequencies. Because they are slightly different in their frequencies, the waveform will be slightly out of phase. So not complete out of phase, it is very slightly, because we are using in one channel, we are using 4000 hertz. In the second channel, you are using 4000 to 4150 hertz. That means it is slightly varying. The frequency is slightly varying, which leads to the waveform which are slightly out of phase. And when these are superimposed within the tissue, they interfere with one another, and the result is that you produce a low frequency current. So this is the principle of production. Now let us try to understand this interference properly. So when it comes to the interference of the waveforms, there are three terminology which we should understand: constructive interference, destructive interference, and continuous interference. First, let us try to understand what is constructive interference. Constructive interference will result when there are two sinusoidal waves that are exactly in the same phase. That means both of them have the same waveform. And when the wavelength, everything is same, and when they are superimposed, they result and supplement each other and result in a wave which has amplitude greater than that of the two of them. That means the two get added up and result in a greater amplitude. So this type of interference is called as constructive interference. Okay, what is the easiest example to remember then? So whenever we watch television or when we go to a movie theater, what do we see? We have a lot of speakers connected and all the speakers produce the same waveform. So what happens is the resultant is it results in a loud sound. This is a constructive interference. In contrast to constructive interference, the destructive interference results when the two waves are which are differing by half the wavelength. That means they are exactly opposite to each other. So you can see in this diagram that these two waveforms are exactly opposite to each other. So when they are superimposed, they cancel out each other and the resultant is null. That means there is completely destruction of the waveforms. So this type of interference is called as destructive interference. And the best example I can give you for this is the muffler or the silencer of the vehicles. So generally, you know that if the silencer is not present in a vehicle, they make very loud sound. To reduce that sound, there is a muffler or a silencer added up. The silencer, what it does is it produces the same waveform exactly opposite to what the vehicle produces. So they cancel out each other and that helps in reduction of the noise. Apart from this, the one more example I can give you is the jammer, cell phone jammer. The cell phone jammer also produces exactly the opposite waveform that of the original towers. So the signal from the tower which is received exactly that is opposed by the jammer and thereby they cancel out and the mobile will not receive a signal. This is about the destructive interference. Now, in the third case scenario, we have a continuous interference. Let's try to understand the continuous interference. This is the basis for the production of interferential currents. So how is this continuous interference happening? One, when we have two medium frequency currents, one of them is fixed at 4,000. The second one is slightly greater frequency, that is 4,150 hertz. In this example, I have used 4,150 hertz. So when they are superimposed, the resultant waveform is that they cancel out at some areas, they add up at some areas. So what is happening is there is a resultant amplitude which is varying, that is which is increasing and decreasing. And what we see is there is cancellation at, that is destructive interference happening at some phases, and there is a constructive interference happening. And the resultant frequency is 150 hertz, that is a low frequency current. So here we have used two medium frequency currents and the result is such that the resultant is of low frequency current. Now, let's go to the block diagram of the microcontroller of the interferential current therapy. So here, basically, if you see this block diagram, we need to understand few concepts. The first one is there is a microcontroller and the source of the, there is a source of current either through battery or through the AC source. And then there is a display to show the timer and intensity of the current. And basically the important part of the interferential current is oscillator. So you have two oscillators. That means you can assume that there are two different medium frequency production unit. So there are two medium frequency current units. So both produce at different frequencies. So here one is fixed, which cannot be altered. And then there is a gain control directly to the power, which connects to the power amplifier. So this basic function of the oscillator is to produce medium frequency currents. So the oscillator produces the medium frequency currents. The power amplifier drives them and increases the intensity. And finally, the output from the each channel is available in both the different electrodes. Now, what are the advantages of medium frequency current over low frequency? So the first advantage is the medium frequency currents offer less skin resistance. That means the skin offers less resistance to the medium frequency current. Then second thing is when the resistance is less, the comfort is much more better than that of the low frequency current. We cannot tolerate a high intensity of low frequency current, but we can tolerate more intensity when we are using medium frequency currents. And finally, the tolerable penetration also increases because we can increase the intensity. We don't have the limitation of increasing the intensity. We can increase the intensity better than that of the low frequency current, like tens. Now let us understand the concept of impedance and resistance. So we come across these two terminology whenever we are referring electrotherapy. So generally we use the word resistance whenever we are using direct current. And when we are using the alternate current, we use the word impedance. So here we are using two medium frequency alternating currents. That's why we need to use the word impedance, and the letter is denoted by Z. And both the units are measured in ohms. Now, there is more to talk on impedance. So we know the formula Z is equal to 1 by 2 pi Fc, whereas the Z stands for the skin resistance or the skin impedance, whereas F is the frequency which is measured in hertz, and C is the capacity of the skin in microfarads. So from this formula, we understand that the relationship of the resistance and the frequency is inversely proportional, and same with the capacitance. So the resistance is inversely proportional to the frequency and capacitance. However, the capacitance of the skin cannot be altered. But what we can alter is the frequency of the medium frequency, that is the current. The frequency of the current can be changed. If the frequency is increased, automatically the skin impedance can be reduced. Now coming to the impedance, we'll take an example to understand it. Let us take a case scenario where the capacitance of the skin is 1 microfarad. And let us apply this in the formula and see. And the domestic current which we receive is of 50 hertz. So we are using again the 50 hertz frequency. And if you apply that, then the resistance offered for a 50 hertz current, the skin offers a resistance of 3200 ohms. And if we take the same, instead of 50 hertz, if we take 4000 hertz, for 4000 hertz, and if you calculate it, the resistance offered to the frequency of 4000 is only 39.8 ohms. So just understand how much less the skin is offering resistance to the medium frequency current when it is compared to the low frequency current. So that is the reason. So this reason has led to the discovery of the IFT. This is the basis for the IFT. So now let us try to understand the functioning of the interferential therapy. So here there are two medium frequency currents which are interacting with each other and producing the low frequency current. So in this two medium frequency current, let us take in one, the frequency is of 4000 hertz, which is fixed. Whereas in the second channel, the frequency can be adjusted between 4000 to 4150 hertz. So the superimposition of one alternating current on the other is called as interference. Now, the frequency of the new medium frequency current alternating can be calculated by the formula F1 plus F2 by 2. So what we are doing is we are using in one channel 4000 hertz and in the second channel 4150 hertz. So when you use this formula F1 plus F2 by 2, the resultant is 4075 hertz. So this frequency is called as resultant carrier frequency, or simply the carrier frequency. Now we come across one more word, amplitude modulated frequency. What is amplitude modulated frequency? The frequency in which the amplitude is increasing or decreasing, which is varying, is referred to as amplitude modulated frequency. In interferential therapy, the amplitude modulated frequency corresponds to the frequencies which are used in low frequency of electrotherapy. So which can be calculated by the difference between the F1 and F2. So that is frequency in the first channel and frequency in the second channel. So in the given example, I can show you the amplitude modulated frequency. That is, if you are using 4000 in the first channel, and in the second channel, if you are using 4050 hertz, the difference is 50 hertz. This 50 hertz is called as amplitude modulated frequency. So the term itself explains you everything. Amplitude modulated. Here the amplitude in the waveform is increasing or decreasing. That's why we are using the word amplitude modification. And it is resulting in a frequency which is the difference of both the medium frequency current. And it is of a low frequency. So that's why we are using the word amplitude modulated frequency. In this example, the AMF is 50 hertz. Now, for the superimposition, the best placement is diagonal. That means the channel 1 and channel 2 or circuit 1 or circuit 2, circuit A or circuit B, they are placed diagonally so that the center point becomes the place where the interference occurs maximally. And the effect also appears to be in the middle. Let us try to understand the parameters used in interferential current. So this is a bit very interesting and everybody should understand this. So here sweep is one of the parameters which we need to understand. So the principle of using the sweep is that the machine is set automatically varying effective stimulation frequency using preset or user setup ranges. So let us try to understand this. So such sweep prevents the accommodation in the nerves. So let us take an example. In this example, let us suppose the base of the channel is 90 hertz and the sweep is set to 40 hertz. Phase or spectrum, both are synonymous. So we can use them. We can use either one of them. So 40 hertz is the spectrum added. So what happens is now the current, the frequency of the current starts from the 90 hertz and it reaches, it increases up to 40 hertz. That means the highest frequency will be 130 hertz, after which again it comes back to 90 hertz. So this process is repeated automatically in the machine. So what is happening is, if you are setting the base at 90 and if you are adding a spectrum of 40 hertz, then what is happening is the frequency is starting from 40, that is the 90 hertz, and 40 is added to the 90. So it becomes 130. So from 40, it reaches the 130, and from 130, again, it comes back to 90. So this process is repeated. Now, next parameter is AMF parameters. So to choose the basic value of the low frequency modulation is desired. So here, the expected low frequency which is useful for treatment can be set by using the AMF parameter. Now, generally in the previous example, it was 50 hertz. And the spectrum parameter, so let us suppose if the spectrum parameter is 90 degrees, suppose what is happening, it will take the same example of 90 to 130 degrees. So the variation in the AMF value is desired. So what is happening is, let us suppose the base is 90. The frequency starts from 90, the amplitude modulated frequency, and it reaches till 130 and again comes back to 90 hertz. So this is called as the spectrum parameter. Now, the sweep time parameter. So the sweep time is the time which is taken for the frequency to reach from 90 hertz to 130 hertz. Generally, most of the equipment are set at 6 seconds. That means for the current to reach from 90 hertz to 130 hertz, it takes 6 seconds. So this is called as the sweep time. So that means the time taken for the frequency to reach from base to peak frequency. This faster sweep is also used for less painful stimulation and strong muscle contraction or strong sensory input. Sweep must be slow to ensure aggressive stimulation. Now coming to the sweep counters. So based on if the intensity is increasing gradually, then it results in a triangular waveform. If the frequency rises rapidly, and then maintained for some time and falls suddenly, this type of rise and fall will lead to a rectangular sweep pattern. And in trapezoidal, there is an gradual increase, and it is maintained for some time and gradually falls. So this results in a trapezoidal sweep patterns. Now coming to the one more parameter, that is the balance. So we are using two different channels of interferential therapy. So two different channels, the intensity is increased. So you can see here in the machine, there is an intensity. Now when you increase the intensity, based on the resistance between the two channels. So this is one channel, this is the next channel. So what is happening is, based on the skin resistance, the output is varied. That means if the resistance is more in one channel, the intensity will be less. To balance the intensity, we have this balance parameter. So what it does is, you can move it towards the red or towards the black. So what happens is, the direction in which you move, that channel receives greater intensity. Okay. So basically what is happening is, you are trying to balance out the right and the left channel. The right and left channel, you can balance it, but the limitation is that it can balance a maximum of 20% of the intensity of the output. Now coming to the next mode, that is the vector mode. So there is an interesting thing called vector mode. In this vector mode, what happens is, this is basically used when you have to treat larger area, diffuse pain, or when you cannot localize the pain. So what happens is, we know that from the previous example that we are placing the electrodes diagonally, and centrally we have got the effective area. This effective area can be denoted by the clover leaf model. Okay, though this clover leaf model was not practically proven, but still this is believed to be theoretically. So what is happening is, basically in vector mode, the machine automatically sets the modulation, and thereby there is a sweep, that is, there is a rotation of 45, 90 or 360 degrees. So there can be 100% modulation or 50% modulation. And here basically what the machine does is, during the vector mode, it automatically sets up so that the effective area is diffuse. That means it is distributed throughout the area, throughout the treatment area. Now there is one more parameter which is called as a rotation parameter. This rotation parameter is applicable in case of vector currents, and that means whenever you are keeping the machine in a mode of vector rather than 2-pole and 4-pole and vector. So when you keep the machine in vector mode, there is a rotation parameter available in which you can set either clockwise or anti-clockwise rotation. Thank you. So this is about the production principle of the IFT. If you have any suggestions, explanations, you can mail me to my mail ID. This is my mail ID. Please note it down, venumohan@gmail.com. Thank you all.